All right, so our next topic is naming acids. And so, naming acids and acids in particular are a little bit different. They have their own system that's separate from our ionic system and our covalent system. And so, the big thing here is that when it comes to acids, you know something is an acid if it starts with basically a hydrogen. So, all acids, and we'll kind of put a note up here. All acids start with hydrogen. And so what that means is in all of our formulas here, we'll call it cation, or the positive side, is always going to be just hydrogen. And so it's pretty much acids are hydrogen paired up with some kind of anion or some kind of negatively charged thing. And so the first type that we're going to talk about are for naming acids that do not contain oxygen, meaning they're not polyatomic ions. And these are called binary acids. Binary meaning it's just hydrogen and one other anion or one other thing. And so with this, the acid name comes from the root of the anion, meaning the negatively charged thing. And the key here is that for all of these, we use the prefix hydro and then the suffix "ic" at the end. So before we were changing the endings to "ide." Now for acids, we change the endings to "ic." And so our steps, super easy. Step 1 is we write hydro. Then step 2 is we write out the name of our anion, and we just change the ending to "ic." So here, our first example, we got HCl. So our anion is chlorine. And so the name of our acid here is hydrochloric acid. So that's pretty much it. Super easy, right? Our next one, HCN. So here, the H is for the acid, the CN is our anion. Now, CN actually happens to be one of our polyatomic ions. So our CN is known as cyanide. So to name our acid, starts off with hydro. So it's hydro, and then cyanide, so cyan, and then the ide ending becomes ic, so hydrocyanic acid. All right, so that's the first type. Now the next type, which is a little bit trickier, unfortunately, is for all of our acids that contain oxygen. Now, for all of the endings or these parts that contain oxygen, these are known as ternary acids. And so as ternary acids, that means that pretty much all of these come from polyatomic ions, or that commit to memory page. So make sure that you guys are looking at that as we're kind of going through this part. So the first part is to identify what the polyatomic ion is. Then the next part is you keep all of the prefixes the same from the polyatomic ion. So the prefixes that are there are like hypo or per. Those are the two that you'll see. So those stay exactly the same. Now, when it comes to writing the rule, it's actually just based off of the name of your polyatomic ion. So that means that there's no hydro involved in these. So it's just the name of the polyatomic ion. Now, like before, we were changing the ending to "ic." The same thing happens. But if the polyatomic ion ends in 8, we change the ending to "ic." And if it ends in "ite," it becomes "-ose." And so to kind of help you guys out with this, the little phrase that helps when you're trying to remember which is which is, I ate something icky. Get it? So the ate, ick, right? And you can say, after I ate something icky, but I had a Sprite and it was delicious. So there's the ite and os endings. So that's a little phrase that, helps trying to remember which ending you're supposed to be using. All right, so let's look at some examples now. And so our first example, we got HClO4. So we look at the polyatomic ion list to figure out what ClO4 is, and ClO4 is perchlorate. And so when we name our polyatomic ion, remember here there's no hydro involved, so it's just perchloric acid. And so that's the big difference between the two systems, is that you know it's just hydrogen and one other element if there's the hydro involved, but if there's no hydro, then it's coming from a polyatomic ion. So that should hopefully help kind of keeping them in mind. All right, let's look at our next one. We got H2SO3. So the name of SO3 is sulfite. And so remember, the ite endings become OUS or OSes. So this is sulfous acid. All right, let's keep on going. All right, now we got HClO. So it's based off of the ClO, and ClO is our, when we look it up, it's hypochlorite. And so since it's hypochlorite, remember we keep the hypo, but we just have to change the ite ending. And so the ites become oses. So this is hypochlorous acid. All right, now going the other way. What happens if we're trying to write out the formulas? So we got hydrobromic acid. So remember, the hydro indicates that it's just hydrogen and one other thing. So bromic, remember we changed the ending, so it would be coming from bromide or bromine. And then we look at the periodic table and see that the charge of bromine is -1. And so then in our formula, since we kind of go back to our ionic rules, the charges have to cancel each other out. So if hydrogen is +1 and bromine is -1, that means our formula would just be HBr. All right, let's look at our next example, permanganic acid. And so that means that it's coming from permanganate, and permanganate is MnO4 with a -1 charge. So just like before, if it's hydrogen and permanganate, we need enough hydrogens to balance out that -1 charge. So we just need 1. So it would be HMnO4. All right. And then our last example, we got sulfuric acid. And so keep in mind there's no hydro, so that means it's coming from our polyatomic ion list or the commit to memory page. And so since it's ic, that means the original ending is 8. So that would be sulfate as our anion, and sulfate as the anion is SO4 with a -2 charge. And so since sulfate has a -2 charge, that does mean we need 2 hydrogens in our acid to balance out that charge. So it's H2SO4. All right, that's it for our notes for naming acids. And our next topic is actually just putting all of our naming together. So make sure you guys have a blank